Okay, so let's do a couple examples with the ideal gas law. So example 1, what is the volume of 6.3 moles of carbon dioxide at 23 degrees Celsius and 555 kilopascals? So again, let's set out by putting out all of our variables that we have. So I can figure out P, V, N, R, and T. Okay, so my pressure is in kilopascals. Remember, with the ideal gas law, pressure must be in kilopascals because that's our R value. If I was going to use any other value of pressure, then my 8.314 number would actually change, because remember, you're doing it with 1 mole of gas at those standard conditions, so you would need to recalculate. So for simplicity's sake, we're always just going to keep pressure in kilopascals for the ideal gas law. So the volume for this one is what we're trying to solve. I have 6.3 moles of my gas. My R is my constant. And my temperature is 23 degrees Celsius. So before we actually do any calculations, I first need to convert my temperature into degrees Kelvin by adding 273 to that. So 23 plus 273 is 296 Kelvin. Okay, so we have two options here. I could plug everything into my equation PV-nRT, or I could rearrange that equation first to isolate for the V so that it's hanging out by itself when I plug everything in. It'll be easier. So that's what I'm going to do, but feel free to do either option. So if I want volume by itself, that means that I'm just going to divide by that pressure. So I have my rearranged equation, volume equals nRT over my pressure. Now I can substitute everything in and solve for my volume. I'm going to include all of my units just so I can keep everything organized for myself. Feel free to put units in at the end. I would like you to carry through this example with units just so that you see how everything cancels out. Okay, with my R value, I'm going to put the moles Kelvin directly on the bottom because remember, that is kilopascals liters per moles Kelvin. So I'm going to hang those guys out down here so that it's already organized. And then I have my temperature as 296 Kelvin here. Okay, and then pressure on the bottom is 555 kilopascals. Okay, so we can do some unit analysis to make sure that everything cancels out. So I have moles crossing out with moles, kilopascals with kilopascals, kelvins with kelvins. I'm left with liters hanging out here, which makes sense because I am trying to solve for a volume. So when you're doing this, make sure that, again, this one doesn't really matter because I only have one number on the denominator, but for all the other ones, make sure that you are plugging it into your calculator properly. So I get the answer that my volume is 27.9 liters. Looking back at the original question, I'm only allowed to express two significant figures, so therefore my volume is 28 liters. Okay, so when you're ready, we're going to do example number 2. So example number 2 is a little bit different, and I'll show you how I can also phrase a couple of the questions in different ways to sort of get different pieces of information out of the question. So example 2, a sample of gas weighs 2.1025 grams and occupies 2.850 liters at 22 degrees Celsius and 98.7 kilopascals. How many moles of the gas are present? And then finally, what is the molar mass of that gas? So just like the last question, I want you guys to start by filling in all of your information of that PV-nRT to figure out what variables I actually have. P V N R T. And if I'm reading through this question, it also gives me a mass. So I have some sort of mass of this unknown gas here as 2.1025 grams. So that doesn't really do a whole lot at the beginning in order to solve for the moles, but we are going to need that as we follow through in this question. Okay, so again, you have a couple options. So as I sub in, you could rearrange the question at the end, or if you prefer to rearrange the question before you actually have any variables hanging out, then that's all right as well. So PV equals nRT. I'm solving for the number of moles, therefore I need to get RT onto the other side here. Okay, so the moles equals PV, oops, oh boy, over RT. Again, I'm going to include all of my units as I carry this through to show how all of my units can cancel out. On a test, as long as the final unit works out, that's good to go, but you should get in the habit of using your units because it really does help you organize all of your information and make sure that everything is rearranged properly. Okay, so my R value, 8.314 kilopascals liters, because it's per, think of this as like dividing by a fraction. You need to flip the second and multiply. So we're going to do that with the units. So my units come up here as my moles Kelvin. Okay, and then my temperature. I have an issue with my temperature. Right now I'm looking at 22 degrees Celsius. This has to, of course, be in degrees Kelvin. So if I add on 273, this becomes 295 Kelvin. Okay, so now I have Kelvin. Now I can substitute everything in, and let's look at all my units. So I have kilopascals, crossing it with kilopascals, liters with liters, kelvins with kelvins. I'm left with the unit mole, which makes sense because I am solving for moles. So when I plug everything in, make sure you're using brackets for your denominator so that it works properly. So I get N equals 0.11469 moles. Okay, I'm not going to round off yet for my significant digits because I'm actually looking for what is the molar mass of the gas. So now I have the moles. And remember back to the beginning part of the question, I also have the mass of my gas. So I can use the equation that we were looking at back in Unit 3 to figure out how much, what the molar mass of my gas is. So remember we had N equals mass over molar mass. So this can be rearranged to figure out molar mass equals my mass divided by the number of moles. Sorry, this isn't a whole lot of room here for you guys. So if I'm going to plug this in to solve for my molar mass, I have my mass is 2.1025 grams. I have 0.1149 moles. So therefore the molar mass of this gas is 18.3 grams per mole. So extension questions that I could ask you from here would be identify the identity of this unknown gas. So looking at the molar mass, 18.3, it's a little far off of our water vapor, but that's probably the closest one of our common gases that we're looking at. So if I found this here and then I gave you a list of unknown gases and said, tell me which gas it is, then you would be able to figure out the molar mass of a gas and say, oh, my brilliant brain tells me that this must be water vapor or water in gas state as the unknown gas. If I saw that the molar mass was, say, 32 grams per mole, then that should hint to you that this would be an oxygen gas. Remember, oxygen is diatomic, so its molar mass would be 32 grams per mole.